Tetraoxosulfate 6 acid is prepared using the chemical reaction this. Okay, so trioxosulfate plus water giving tetraoxosulfate 6. Given the heat of formation for trioxosulfate, water, and sulfuric acid as this, and this respectively, find the enthalpy change accompanying this reaction. Well, according to Hess law, the enthalpy change for the formation of H2SO4 will be the same no matter the path taken. So no matter how you go about it, you will always get the same thing. But let's analyze this properly. Let's analyze it carefully and see what the enthalpy change would be. Let's start with our general standard here. Here, it starts with SO3, trioxosulfate. Okay, to form trioxosulfate, we'll need sulfur plus oxygen. Oxygen is diatomic to give us SO3. Now, to balance this, we need to put a 2 here and a 3 here. Okay, because this is an odd number. That's the only way. Now, sulfur needs a 2 here. Okay, if we compare this to what we are trying to get here, what we want to do is one by one, we're going to analyze this, and this. Okay, and then we're going to place them and see what the energy change, the total energy change will be. We'll sum up the changes after doing that. So we have SO3, which we need here, but we have it 2 moles. We just want 1 mole. So I'll divide through by 2 so that I will have 1 here. When I divide this by 2, I'll have just S plus, when I divide this by 2, I'll have 3 over 2 O2. And then when I divide this by 2, I'll have just SO3. Perfect. This is what I need. This is how I want it to be, because here we have just 1 mole, so it should be 1 mole. Now, another thing is, this is at the reactant side, and as you can see, this is at the product side. So we want to turn it over. So now this is where I'll write out the finished work. So our finished work will be having SO3 on the reactant side. So I'll put SO3 here, and then our arrow to S plus 3 over 2 O2. And here we were told 395. But because we have reversed this equation, this sign will reverse to a positive sign. So we should be having, instead of negative 395, we should be having positive 395. Okay, I'll draw a line there so that you don't think that 395 is part of the equation. All right, let's take up the next compound there. That is H2O, water. The constituent elements are hydrogen, oxygen, and then we'll have our water. This is not balanced. To balance this, we need to make hydrogen 2 here, and of course, oxygen 2 here, and hydrogen 4 here by adding 2. Okay, having done this, we also need 1 mole, but we are having 2, so we must divide downwards. So when we divide by 2, we have 1. We divide by 2, we have 1 over 2 of oxygen, and then we divide by 2, we have H2O. Okay, this is at the product side. We want it at the reactant side, so we'll take it over. So here we have H2O to now produce H2 and half of oxygen. Okay, and because we have reversed it, this minus 286 that was given as the formation for water will now be reversed as plus 286. Okay, now the final one, H2SO4. Let's just take all the individual elements. Hydrogen plus oxygen. Hydrogen and oxygen are diatomic. Sulfur is not, so just sulfur. And then we'll have H2SO4. So when we take the individual elements like this, you see it's only hydrogen that needs oxygen, that needs to be balanced. So we'll put 2 here, and then oxygen is balanced now. Okay, having balanced oxygen, you see it's already positioned properly. It has 1 mole just like we need, so no need to divide through. And it's at the product side just like we need, so no need to turn it over or flip it. So we just take this way. I will present it here as H2 plus O2, that's 2O2 actually, 2O2 plus sulfur to give H2SO4. Okay, so this will be unchanged. So minus 811. All right, let's find out if we actually did a good job by trying to cancel out. So all these that we have on the reactant side are like 1 together, okay, and the other ones on the product side are together. So whatever we have on this reactant side and this product side, we can cancel out actually. So let's look at sulfur. We have 1 sulfur here, 1 sulfur here. It's just like math. Take it over, it becomes, if you take it across, it becomes sulfur minus sulfur. So this goes with this. Okay, so this is 1.5, 3/2. You add half to 1.5, you have 2. So if you take 2 across, 2 will cancel 2. So this goes with this 2, with this 2. They all go. Okay, and hydrogen perfectly goes with this hydrogen. So we are left with SO3 plus H2O to give H2SO4. And it matches the description in the question. It means we did a good job. Now we can go ahead and add this. So let's add. We have 3, 9, 5 plus 2, 8, 6 plus, not plus this time, sorry, minus now, minus 8, 1, 1 equals, we have minus 130 kilojoule per mole. And that's our final answer. Easy.